Hello, students. Before we get started, I wanted to talk to you about the organization of the lesson a little bit. I see some of you on February 4th, so this is your do now and your informational box. Here's your do now. And I see some of you on February 5th, so here's your informational box and your do now. But the lesson for today for both classes, whether you're here on the 4th or the 5th, is the same. We're just going to do some comparing of the methods for solving systems, and then we will do some review. So let's get started with our do now. Make it a little bigger so we can see it. So we're first going to carefully respond to a prompt about practicing gratitude. That's for Thursday. We're having a thankful Thursday. And on Friday, your prompt will be a little bit different. You've got a prompt about forgiveness. Excuse me, students. So let's go back to our informational box. Today we will compare and review methods for solving systems of equations. So we've been graphing, we solved by substitution, and then we solved with elimination. So our essential question asks, what are the advantages of one method solving systems of equations over another method, and how is each method better or not? Your assignment will be to complete the do now in your class notebook, to watch the video and complete the 2 assigned pages, and answer the exit ticket in class notebook. Make sure you upload your completed assignment in Teams. For your exit ticket, it's very personal today. I want you to insert on this line your favorite method of solving systems of linear equations. And again, reminding you to upload your assignment in Teams. That's your participation credit. For homework, we have homework 5.5, solving systems, all methods, all problems. It's 2 pages, but you have until Monday morning to turn that in at 8 o'clock. So let's remember, to get full participation credit, your camera is on. You respond when your name is called at the beginning, middle, or end of the period. And always look for opportunities to clarify your knowledge through extra practice. If you have any questions, please write to me. So, a little reminder that a job well done means a job done honestly. Please respect the honor code when taking any tests online, whether that's a math test in Teams or the MAP test that you're taking this week. For the Thursday group, we want you to note 3 ways that you can practice gratitude or being thankful. And please write that right here. I'm so thankful this week for you, your hard work, for my grandchildren, and for the opportunity to teach. We'll get to our exit ticket in a minute. Let's look at the do now prompt for February 5th. And also, we want to remind you, spend time this weekend thinking about you can be an amazing distance learner and how your education can be enriched by this experience. This isn't a throwaway year, students. You have this opportunity, especially in algebra, to actually learn more than ever. We're learning it a little differently, but it can be a very individualized experience for you. And without the distractions of sometimes that we have in school, you can really ace algebra and get very proficient. And so our Friday do now is about forgiveness. To forgive means to stop feeling angry or resentful towards someone for an offense, flaw, or mistake. How long should you wait before you offer forgiveness to someone? That's a complicated question, I know, but let's put some thoughts down right there. So let's get to our lesson today. We're comparing methods to solving systems of equations. And as it says here, systems of equations can be solved by graphing, substitution, or elimination. However, there are situations where one method may be more sophisticated than another. Solve the following systems using the graphing, substitution, or elimination method. You may only use each method once. Okay, so let's look at system A. I see x minus y equals 2. And I can easily rearrange that so that I have, if I just move y to the other side of the equal sign, I will have x equals y minus 2. Now I can easily substitute that y minus 2 for x in the second equation. So let's do that. 7, and I'll substitute y minus 2 plus 2y equals negative 5. So first we distribute. That will give us 7y minus 14 plus 2y equals negative 5. Now I can combine 7y plus 2y, so I have 9y minus 14 equals negative 5. Then I'll add 14 to each side, which gives me 9y equals 9, and then y equals 1. Now I will take the 1 and substitute it in, I'm going to go ahead and substitute it into this equation right here. So I will have x equals 1 minus 2, and x equals negative 1. So our ordered pair, negative 1, 1. And you can graph that on Desmos. And what we did here, we substituted, we used substitution to solve that equation because one equation was almost already solved for x or y. And that's when you'd use substitution. For the second equation, I'm looking at 8x plus 5y equals negative 13, and 3x plus 4y equals 10. And I think I'm going to work with this 5y and 4y. So what is the least common multiple of 5y and of 5 and 4? And that would be 20. So I'm going to go ahead and multiply this first equation times 4, and the second equation I'll multiply times 5, and let's rewrite those. So 8 times 4 is 32x. 4 times 5 is 20, so plus 20y equals negative 13 times 4 is negative 52. And the second equation, 5 times 3, that will be 15x. 5 times 4 is 20, so plus 20y equals 5 times 10, which will be 50. And then I'm going to go ahead and subtract the second equation from the first. 32 minus 15 is 17x. The y's are eliminated. Negative 52 plus negative 52 minus 50 is negative 102. Divide both sides by 17, and x equals negative 6. Now I will take that negative 6, and I'm going to go ahead and use the second equation. The numbers are a little smaller, and I will substitute x for negative 6. So 3, and there's our substitution of negative 6 plus 4y equals 10. 3 minus 6, 3 times negative 6 is negative 18 plus 4y equals 10. I'll add 18 to both sides of the equation, which gives me 4y equals 28. I'll divide both sides by 4, and y equals 7. And my solution is negative 6 comma 7. So I used elimination to solve that equation. So I guess we're going to be graphing this next equation. So we haven't used that method yet. And what we need to do is, if we're going to hand graph this, we need to put this in slope-intercept form. So the first equation, we have 4x minus 3y equals 18. So I will subtract 4x from each side. We're solving for y here. So I have negative 3y equals negative 4x plus 18. I'll divide everything by negative 3. And that gives me y equals, and negative divided by negative is a positive, so y equals positive 4/3 x minus 6. So this is the first equation. The second equation, all I need to do is subtract 2x from each side, and that will give me y equals negative 2x plus 4. So I've got these two equations, y equals negative 2x plus 4, y equals 4/3 x minus 6. So we're going to have to graph these by hand. I think hand graphing is good practice. I don't want you to just jump to Desmos. Let's hand graph them. So here's our y-axis. And here's our x-axis. And we'll make each one of these units equal 1. So our first equation was y equals 4/3 x minus 6. So we're crossing the x-axis at negative 6. And we have a positive slope of 4/3. So 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. So this is our first equation. Let's choose a color. Let's choose red. And that's for our y equals 4/3 x minus 6. So let's work with green for y equals negative 2x plus 4. Our y-intercept is positive 4, and we have a slope of negative 2. So down 2 over 1, down 2 over 1, down 2 over 1. We can actually see our solution already. So let's graph that carefully in green. And we can clearly see our solution here, which is positive 3, negative 2. Let's go back to our paper. 3, negative 2. So let's move on. We'll solve some more equations. So we have to put each of these in slope-intercept form to solve them by graphing. So let's get a color. We just have to move x over for the first one. So the first equation is x minus y, excuse me, not x, y minus x equals negative x plus 3. That's the first equation. Now the second equation, I'll work that up here. 3x plus 2y equals 14. Subtract 3x from each side. And we have 2y equals negative 3x plus 14. Divide everything by 2. And we have y equals negative 3 over 2 x plus 7. So first equation, we have our y-intercept of, whoops, it should be positive 3, and a slope of negative 1. There's a slope of negative 1. Don't forget your arrows. And the second equation, y equals negative 3 over 2 x plus 7. So I'll choose another color for that. That'd be y-intercept of 7. And a slope of negative 3 over 2. 1, 2, 3, 1, 2. 1, 2, 3. 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Well, there's our solution to the equation right there. Let's graph that line. And it looks like the solution to our equation is 1, 2, 3, 4, 5, 6, 7, 8 on the x-axis and negative 5 on the y-axis. Right there. Okay, the next equation, x equals 4. That's really easy. We can just graph that quickly. 1, 2, 3, 4. So here's our x equals 4. And we're going to move x to the other side. We're going to have 2y equals negative x plus 6. Divide everything by 2. And y equals negative 1/2 x plus 3. So let's change our color. And we have a y-intercept of 3 and a slope of negative 1/2. And there's our solution right there. Let's graph that line. And the solution appears to be 4, 1. Right there. Okay, number 3 and 4. So number 3, 4, 5, and 6, we're going to solve by substitution. So we are already solved for y. So we will put 7x plus 6 where y is. So that gives us 4x minus 3 times the quantity of 7x plus 6 equals 16. We will distribute 4x minus 21x minus 18 equals 16. We'll combine like terms. 4x minus 21x is 17, negative 17x minus 18 equals 16. We'll add 18 to each side of the equation. Negative 17x equals 34. Divide by negative 17. And x equals negative 2. So let's substitute x equals negative 2 in the first equation for x. So y equals 7 times negative 2 plus 6, which is negative 14 plus 6. So y equals negative 8, and our solution is negative 2, negative 8. Now, in the second equation, I'm going to solve this for x by just moving the 7y over, which will make it positive. X equals 7y minus 21. Now, I'm going to substitute 7y minus 21 for x in the second equation. So 2 times x, which is now 7y minus 21, minus 14y equals negative 42. And then I will distribute. That gives me 14y minus 42 minus 14y equals negative 42. I think you can see what's happening already. When I combine the y's, they are eliminated, and I end up with negative 42 equals negative 42. And this is one of those infinite solution equations. Both lines are indeed the same line. Now in number 4, I'm going to solve the second equation for x by moving negative 4 to the right side of the equation, and that will give me x equals 4y plus 12. And I will substitute 4y plus 12 for x in the first equation. So 3, and instead of x, I've got my 4y plus 12 minus 5y equals 15. And I distribute. 3 times 4 is 12, so 12y plus 3 times 12, 36, minus 5y equals 15. 12y minus 5y, combining like terms, is 7y plus 36 equals 15. I'll subtract 36 from each side. 7y equals negative 21, and when I divide both sides by 7, y equals negative 3. Now I will substitute negative 3. I think I'm going to go ahead and pick this equation here. So x equals negative, well, first 4 times negative 3, so I don't want to forget the 4. 4 times negative 3 plus 12. 4 times negative 3 is negative 12 plus 12, so x equals 0. So my ordered pair is 0, negative 3. And next one's number 6 is a little bit easy. It's already solved for y. So I will insert negative 5 for y in this second equation. 8x plus 5 times negative 5 equals negative 17. 8x plus positive 5 times negative 5 is going to be negative 25 equals negative 17. Then I'll add 25 to both sides of the equation to get 8x equals 8, and of course x equals 1. So y has already been solved for us. So x equals 1 and y equals negative 5. So for the last 4 problems, we'll solve those by elimination. So taking a look at number 7, I will just subtract the second equation. Then I will eliminate the x's by subtracting. And negative y minus negative 6y is negative y plus 6y. So it's negative 1 plus 6, which is 5y. And negative 10 minus negative 25 is negative 10 plus 25. So negative 10 plus 25 is 15. I divide both sides by 5, and y equals 3. I'll insert 3 for the y in the first equation. x minus 3 equals negative 10. Add 3 to both sides. And x equals negative 7. So my ordered pair is negative 7, 3. Number 8. I've already got this positive 2y and negative 2y, so I'm all set. I'm just going to add these together. The y's are eliminated. 8 plus 2 is 10x. 28 plus 22 is 50. Divide by 10, and x equals 5. So I'll substitute the 5 in for x in this first equation. So 2 times 5 plus 2y equals 28. So I'm solving for y here. 10 plus 2y equals 28. Subtract 10 from each side. 2y equals 18. Divide both sides by 2. And y equals 9. And my solution is 5, 9. And number 9, I've got 3x and 1x, 6y and 2y. If I multiply this first equation times 3, let's see what happens. So the second equation by 3. So the first equation is 3x plus 6y equals 27. The second equation is 3x plus 6y equals 33. So if I subtract the second equation from the first, 3x minus 3x eliminates the x's and the y's are eliminated. So I end up with 0 equals 27 minus 33 is negative 6. 0 does not equal negative 6. This is a no solution equation. And finally, the last problem. I've got 4 and a 7 and a 5 and a 3. I think I'm going to work with the 5 and the 3, and the least common multiple of 5 and 3 is 15. So I'm going to go ahead and multiply the first equation times 3, and I'm going to multiply the second equation times 5. And when I do, that will give me 12x plus 15y equals 66. And the second equation, 7 times 5 is 35. That's 35x minus 15y, because it's negative 3y, so that would be minus 15y equals negative 32 times 5 is negative 160. So we've eliminated y. So let's go ahead and just add these two together, which is what allows us to eliminate y. So 12 plus 35 equals 47x. So 47x equals 66 minus 160 is negative 94. And I'll divide both sides by 47. And x equals negative 2. And then I'll go ahead and I'll substitute for x in this. Let's use the second equation. So, and I better change the color. So I'm going to have 7x instead of x, negative 2, minus 3y equals negative 32. So that would be negative 14 minus 3y equals 32. And I'll add 14 to both sides, which will give me negative 3y equals negative 32 plus 14 will be negative 18. And divide both sides by negative 3. And y equals 6. So my solution is negative 2, 6. Now, up to our exit ticket. You have been asked, my favorite method of solving systems of linear equations is, I can't answer this for you. Is it graphing, substitution, or elimination? Put your answer there. Students, you really need to practice these. You'll be very good at your basic algebra as you do systems of equations, because there's a lot that we can use from our algebra toolkit. So just keep on practicing and write to me with any questions or come to extra help sessions. You're doing a great job. Keep practicing, and as you do, you'll be great.